Locus of a point sounds pretty simple, a singular point. However, it can be a circle or even an ellipse. So, which one is it? To understand locus as a whole properly, let's take a look at the circle of radius 5 and try to find its locus. Angle in a semicircle theorem. The two ends of the diameter can be connected at the circumference forming a right angle, as you can see over here. Now, this condition is satisfied across all the points other than points A and B themselves. What do? We turn the diameter by a whole 90 degrees. Now, this condition is satisfied across the previous point A and the previous point B, as you can see over here. Angle formed in each case, we see that our diameter is the hypotenuse with its midpoint being the origin. By the distance formula, we get the squared value of each side. What is this for? By applying Pythagoras theorem, we see that each side simplifies to a final equation. This equation is basically the equation which each point satisfies in our circle. As you can see over here, it's x square is equal to a square plus b squared. Here, x is nothing but the distance of the circumference from the center of the circle. In essence, it's simply the radius of the circle. Over here, a and b simplify to x and y coordinates in the circumference. Now, over here radius is 5. Plug in that into our equation, we get 25 is equal to x square plus y square. Let's test for rational numbers. X is equal to 3 and y is equal to 4. And let's plug those in. As you can see over here, the equation is satisfied. What about irrational numbers though? Such as root 7 and root 18. Let's plug them in. As you can see over here, the equation is satisfied again. Irrational numbers are incomplete and can't exist as a point on the axis is false, and I'm gonna prove it. As you can see over here, I have a right angle triangle, and by Pythagorean theorem, the hypotenuse is root 2 in length. Now I'm gonna rotate this hypotenuse by 45 degrees so it lands on the axis. Now the point where this line or the hypotenuse ends is gonna be the length of root 2, and hence that exact point can be described as root 2 on the x-axis. Rational numbers exist, but why can't we find their exact value? It's simply a limitation of our decimal notation. 5 root 2 is approximately equal to 7.071. That's the best we can do. A person exists even when we can't spell the name properly. It's our limitation, not the person's. Watching this video, I really hope you enjoyed it and understood the concept clearly. Make sure to like, share and subscribe, as these videos take me a lot of effort. And I will see you in another video.